And we are alive. GM, welcome everyone to this new first flight. Today we have yet another interesting project. And as you already know, first flights are our efforts to make smart contract auditing competitions more accessible for the community. In these projects, you can earn a lot of experience, learn a lot about auditing and security vulnerabilities, and create yourself a reputation on the community. Today we have an interesting project because it's related to one of the lessons we have on one of our courses on Updraft. So let me share my screen and show you what I'm talking about. In this first slide, number 18, we have TSwap. This is a decentralized exchange, better known as a DEX. I actually prepared some graphs for you today to explain how all the system works, but let's go step by step. First thing first, don't forget to open the GitHub repo, clicking on View Repo, and don't forget to clone this inside your machine. I already have it on my terminal, and don't forget you need to always install the dependencies and the libraries used on this project using the command make. I already have it, but on the meantime, I'm explaining the rest of the project. Please don't forget to clone the repo and execute the basic installation first. So let's return to the web page. If you haven't have taken the Cypher Opera Security and Auditing course, TSwap is going to be really familiar to you. Please, a little disclaimer over here. The point of participating on these first flights is for you to learn and become a better auditor. So technically going to Updraft and checking this lesson about TSwap is a little bit of a trick. I mean, you better don't do that. It's especially if you want to actually learn, you can just go there and get the answers. But the whole point for you is to actually learn, right? So let's continue. As always, you can always see how many experience you are going to get for each one of the submissions you get, what is the end log, how complex the code is. So let's go ahead and explain what this project is about. This project is meant to be a permissionless way for users to swap assets. Actually, let me make this even bigger for you to see. Okay. This project is meant to be a permissionless way for users to swap assets between each other at a fair price. You can think of TSwap as a decentralized asset token exchange, or DEX. TSwap, is known as an automated market maker, AMM, because it doesn't use normal order book style exchange. Instead, it uses pools of an asset. It's similar to Uniswap. If you want to understand better how Uniswap works, you can open this explanatory video, which is going to lead you to YouTube. Now, let me explain how all of this means. It says that TSwap is not a normal order book style exchange. What is an order book style exchange? I prepared some graphs for you today. So basically, when you want to buy or sell tokens on any given exchange, you have, of course, buy orders, people wanting to get an asset, and sell orders, people wanting to sell that order. On a traditional system or on a traditional order book, there is a bid price, is how much money the buyer is willing to pay for an asset, and the seller price or ask price is how much the seller of the token is asking for that price. The differentiation of the difference between the bid price and the ask price is known as the spread. The liquidity pool then is created based on how many buy orders and how many sell orders they are on the market. So the more sell and buy orders there is, the bigger the liquidity pool. However, this type of order book exchange are traditionally centralized and require you for approval in order to make a sell or make a buy. In differentiation, TSwap works, as already said, as a decentralized exchange and is also a permissionless exchange. The way TSwap works is as follows. Let me show you here. Inside of the exchange, you have something called liquidity pools. Each liquidity pool is a pair of tokens. DAI wet, USD wet, or any token wet. For the case of TSwap, all the tokens or all the pair tokens are always paired with wet. Let's take wet as the base token for the whole system. You can get any token you like, but you always be trading using wet. If a user, in this case you, want to use the exchange, this is what's going to happen. Let's say the buyer wants to buy or exchange 10 USD dollars into DAI token. Well, they are going to interact with the USDC/WET pool. They are going to get WET in exchange, and then they are going to use that WET inside of the DAI/WET pool to get the DAI tokens. The user can execute those functions or these functionalities using both of two functions on the protocol, a swap sat input and swap sat output. I'm going to explain a little bit later how this function works when I show you the code. So basically what happens at the end is that you enter your tokens and receive another tokens in exchange. However, in differentiation of a normal order book marketplace, here, as you see, the liquidity pool was based on how many orders we have. Though here, we need to have those liquidity pools already on the exchange. And for that, we need people or other users to act as liquidity providers. The liquidity providers are people that put their own tokens inside the exchange and let other people to trade with them. You might be asking why anyone would want to give tokens to exchange. Well, because the exchange takes a fee. So, for example, in this operation, the buyer has 100 USDC. He wants to convert it to DAI again. So the user interacts with the USDC/WET pool. This pool has a 0.3% fee. So basically, if the pool has 1,500 WET and 1,500 USDC, the user at the end, instead of getting $100 worth on WET, they are going to have just 99.7 USD worth in WET because the user is paying this fee. This fee is what the liquidity provider earns just for allowing other people to trade with their tokens. With that explained, this is more or less how the basic functionality works. Let's check let's check this a lot more in detail. So, TSwap pools. The protocol starts a simply pool factory contract. This contract is used to create new pools of tokens. It helps make sure every pool token uses the correct logic, but all the magic is in each TSwap pool contract. You can think of each TSwap pool contract as its own exchange between exactly two assets, any ERC20 and the WET token. These pools allow users to permissionless swap between a ERC20 that has a pool and WET. Once the node pools are created, users can easily hop between supported ERC20s. Now, as you can see, how this works is that we don't have a common or just one smart contract for the TSwap pool. For each pair of tokens, let's say DAI, WET, USDC WET, we create another instance of the TSwap pool. So we have one pool factory. This pool factory is the one which is going to create more TSwap pools depending on the pair we want to trade. For example, a user has 10 USD, what I already showed you. It wants to buy DAI. They swap 10 USD for WET in the USD WET pool, and they swap their WET into DAI using the DAI WET pool. Every pool is a token X and WET. This token could be anything, but remember, the common currency using in this exchange is WET. Then we have the liquidity providers. As I already explained, these are people that allow you to transact with their tokens because they are going to get a small fee after each transaction. Also, when you deposit into the protocol, you are going to earn something called LP token. You'll notice TSwap pool inherits the ERC20 contract. This is because TSwap pool gives you an ERC20 when liquidity providers deposit tokens. This represents their share of the pool, how much they put in. When user swaps funds, 0.03% of the swap stays in the pool, netting LP a small profit. So basically, you swap the tokens, the liquidity pool gets a small fee, and that fee supports the LP token liquidity providers are given for providing their tokens for trading. Here we have another example. So a liquidity provider adds this amount of WETH and USDC for one pool. Another liquidity provider adds more funds to the same pool. They are going to get this amount of liquidity provider tokens. Then this is the total pool inside of the protocol. A user wants to make a trade, and finally the user ends up paying some fee to the liquidity provider or to the liquidity pool in order to be able to get that exchange. At the end, the pool balance is going to move one token to another. Notice that in practice, the pool would have slightly different values than these ones. Basically, it means that even though the fee is 0.003, the numbers are not going to match always as expected. And there is a reason behind that, and is because of the math. Our system works because a radio of token A and WETH always stays the same. Well, for the most part, since we add fees, our invariant technically increases. Remember, for those of you who haven't, who already have taken one of our courses about fuzz and invariant testing, fuzzing is the ability we have to input random parameters to a test in order to break it. For that, we need something called an invariant. An invariant is the condition our system must always hold. If a condition is broken, it means that we have broken that invariant. For that, I'm going to recommend to you to take a little bit a look to your math notebooks because you are going to be tinkering a little bit with these math equations over here. You know, when we transfer and make transactions, we always do using the fees in terms of way. That's why the math is not exactly the same always, especially because this rule, as we are adding fees, technically our invariant increases. This might be contradictory because if this is an invariant, the invariant should never change, right? And this shouldn't increase ever. That's something I'm going to let to you to discover when you audit these smart contracts. Basically, I'm going to explain a little fast this math. We have Y representing the token balance, or one of the token balances. X is another token balance. K, which is the constant ratio, X and Y, is the multiplication of both. Then we have delta X and delta Y. This represents the change on the balance of the token X and the change on the balance on the token Y. And then we have beta and alpha, which is delta Y divided by Y and delta X divided by X. And the final invariant equation without the fees is this one. I'm going to highly recommend you for this project to hone up your skills on fuzz testing, because if you want to break this invariant somehow, you are going to find a lot of vulnerabilities. Zumba okay, student, I am your maths teacher. Let's study. 1 plus 1 equals 2. Yes, that's exactly what we are expecting. Though this is a little bit more complicated, and you are going to find that when you are auditing this project. Also, you might be tempted to do some formal verification here in order to be sure the math is correctly working. So I'm going to leave that to you. For making the swap, after a pool has liquidity, there are two functions users can tell to swap tokens in the pool. Swap exact input or swap exact output. Sorry, my pronunciation. A user can either choose exactly how much to input. Example, I want to use $10 of USDC to get however much wet the market says it is. Or I can choose how much exactly I want to get. For example, I want to get 10 wet for however much USDC the market said it is. Basically, if you say swap exact input, you are going to input any amount of tokens and you are going to get what the exchange says the exchange rate is. Or you can say swap exact output. In this occasion, you specify how much you want to get, and the exchange is going to require you to pay the X amount of tokens the exchange is supposed to use. This code base is based loosely on Uniswap v1. Right now, I think we are on Uniswap v4, if I'm not mistaken. So I don't think tinkering a little bit with Uniswap v1 is going to be that much of a hassle. I already asked you when I started this live to clone this repo and use make. Always don't forget you can check how many functions are tested here. If you use some forge coverage, this is going to give you information of how many tests are covered on this smart contract. And seems I have not configured correctly my remappings for the Open Zeppelin contracts, and this is creating me an error. Actually, let me check. A little bit of troubleshooting here. On my make file, I should have over here the installation of Open Zeppelin, but it seems it's missing somehow. So maybe I will do a make install. This would solve the problem. Let's wait a second. Yep, it just installed an Open Zeppelin contract. So let me clear my terminal and actually use forge coverage again. And now the problem is solved. You know, sometimes you get ready for these lives. You test the code beforehand, and when you enter the live, somehow your code stop working. But most of the problems are lazy, easy to solve ones like this one. Never mind, let's continue. So as you can see, we use for coverage. This is going to give me the information on how many functions or tests are covering. Remember that the deploy script is actually not on the scope, so you don't have to put attention into this, but to the pool factory and the TSwap pool.sol. And as you can see, the coverage is a little bit slow. Let me Let me make this a little bit smaller. Run the command again. And then we have the information. Okay, so 60% of the functions on the pool factory are covered. It means 3 out of 5. And inside the TSwap pool, we just have 9 out of 20 functions covered. Again, if you want to find vulnerabilities, you need to be sure each function does what the function is supposed to do. One way to find vulnerabilities is to make a function to do something that the function is not supposed to do. Finding that weird scenario in which the function performs something that it shouldn't. Let's continue over here with what's next on this project. Actually, let me open again this. You have here the scope, as always. The actors, well, as already explained, we have liquidity providers, people that send funds to the exchange, and they get their shares represented by the liquidity pool ERC20 token. They gain a 0.3 fee every time a swap is made. Again, user makes a swap, the liquidity pool retains this fee, and the representation of this fee is on these ERC20 tokens. And the users are the people who just want to start exchanging tokens, and there is no known issues on this protocol. Let me open the smart contract. The pool factory is actually a really interesting a really interesting smart contract because it's just a factory contract. This smart contract is in the responsibility of this smart contract, is to create a lot of TSwap pool contracts. So basically, inside of TSwap pool, we put a pair USDC slash wet, DAI slash wet, link token slash wet, and each TSwap is going to have its own liquidity pool. And yeah, I think this is more or less it. Actually, let me check a little bit the comments on the comment section here. Echo says 1 plus 1 equals 3 for very large values of 1. I'm not going to discuss that right now, actually. This out of nowhere, I have a question in mind. In Python, 0.2 plus 0.1 equals 0.30004. Yeah, this is a common issue. This also happens in JavaScript, if I'm not mistaken. And the reason is because the way the memory is managed on these programming languages is a little bit strange. I actually know the answer for this, but not the technical answer. I saw this problem uncountable times. I'm going to leave the community members on Discord to help you solve this question. But yes, you're right. This happens on programming languages like Python and JavaScript because the way it manages floating point numbers is a little bit weird. Good question. Viper, like Solidity, probably doesn't handle floats very well. Yeah, that's what I was saying. Jean-Claude Van Damme said 1 plus 1 equals 1, and I trust him. I don't want to be beat. Okay, that was pretty nice. Well, I'm deviating myself for the main topic here. I hope you enjoyed this basic explanation of what TSwap is and what this auditing contest / first flight is. I hope you hone up your skills as an auditor. Be sure to perform fuzz tests on this code and also do some formal verification in order to verify the math is working as expected. That was it on my end. Don't forget, if you have any questions, doubts, and you don't know how to submit the project, etc., you can always reach out on Discord, and our community manager, Superstar Ekios, is going to be there always ready to help you. Thank you very much for this. And if we don't have any other questions, I think we are safe to go. Ekios say, happy Friday, Bas. Thanks for the walkthrough. It's my pleasure. See you on the next Speech Flight. Bye-bye.